to just be mindlessly watching this video. I expect you to kind of be engaged. Okay, so I'm just going to go ahead and start here with our first statement here. I'm going to say all of the given, which is that YW bisects XZ and that XY segment is congruent to YZ segment. And that's all of that's given. And I'm going to go ahead and mark that this segment's congruent to this segment because that's in the given. Can anybody see anything else that would be congruent to anything else in this problem based on what the given information is, or just based on the picture?
X would be congruent with Z.
Angle X and angle Z?
Yes.
That is going to be true, but we don't know that quite yet, Sean. But you're right. It is going to be congruent. But based on the given, we're not quite there yet.
Come on. What else is congruent in that picture, guys?
Okay, I'll give you guys a hint. If this right here, this segment YW bisects segment XZ, does anybody know what we can conclude on that? If this segment bisects this segment. Ishmael?
I might be wrong, but I'm just gonna swing. I don't know. XWY.
XW.
And ZW.
ZW. What's true about them?
They're congruent.
Absolutely, Ishmael. That's exactly right. So step 2 is XW is congruent to ZW, and that's going to be by the definition of segment bisector. So we were told that this segment bisects this segment, so that means that it, or W, is a midpoint, therefore that segment's congruent to that segment. Now I'm hoping that you guys can see that one thing right now that we use very often, and I don't want to give you a hint too much, but the hint is this: it's in both triangles already. There's one more thing that has to be congruent because it's in both triangles.
YW
is congruent to what, Ishmael?
YW.
Correct. And what's the reason?
Reflexive.
You are absolutely correct, sir. Ishmael, it's quite a shame that you're not here in person, because right now on this day, I would be giving you the gold brick, because not only did you help me out with step 2, you just helped me out with step 3, and you gave me the reason. So I want to award you this. Now I'm having to do it virtually. I'm awarding you this virtual gold brick, December 1st, 2020. Thank you, Ishmael. Congratulations, big guy. Okay, so this is going to be congruent to this. Now, step 4, triangle XWY is congruent to triangle ZWY. Someone besides Ishmael, could you tell me why those two triangles would have to be congruent looking just at the picture?
Because they're vertical.
No. There's no vertical angles here. Okay, I'm going to speed this up, guys, because we have other things to get done today. Because of S, side, side, side. You have 3 corresponding sides in this triangle, congruent to 3 corresponding sides of that triangle. So those 2 triangles are congruent because of side, side, side. So now we can get to our last step of this proof, which is that angle XYW is congruent to angle ZYW. And someone please make my day besides Ishmael. Ishmael, you've already made my day. That's why you got the gold brick. Can anyone tell me the reason for number 5?
CPCTC.
Absolutely, Sean. That is exactly right. CPCTC. Now, guys, I'm hoping that this seems very familiar. We've done these proofs. You had a test on it last week, right before Thanksgiving. This is kind of the gist of what we've been doing for the last several weeks. And this is the kind of thing that you're going to be asked to do on the final exam, okay? We're not going to have the final exam until a couple more weeks, but it's not a bad idea to go ahead and start reviewing some of those things right now. And again, let's just go and go to the next slide. I have a very important announcement that I want to make right now for some of you that have missing work. I made an announcement in Canvas. I hope that you saw that announcement. I just made it this morning at 8. Actually, I think it was right at the beginning of this class. If you haven't seen that announcement, I would encourage you to make sure you look at it. It's very important and it regards missing and makeup work. And the only thing I want to say about it in this presentation, because I want you to read the announcement, is 9 p.m. on Friday, December 11th. 9 p.m. Friday, December 11th. That's a very important date and time for you in this class. So please make sure you read the announcement in Canvas. Okay, so today we are going to look at something called midsegments. That's section 5.1. So we're looking at section 5.1. And a mid-segment of a triangle is simply a segment that joins any two midpoints. So here I have triangle ABC, and let's go ahead and get this guy right here, and we'll call that, this is point M1, and I'm going to call it M1 because it's a midpoint. And then down here at the bottom, let's say this right here is M2, and that's because it is also a midpoint, so this segment's congruent to this segment. Then this green segment that I draw right here, this green segment, that is called a mid-segment. A mid-segment is simply a segment that joins any two midpoints within a triangle. Now, obviously, this triangle could have more mid-segments. In fact, if I wanted to, I could draw one that's over here, and I could draw another one that goes from here to here. But this segment right here, segment M1, N2, is what we call a mid-segment. And we're going to look at some theorems about this. So here's our theorem. Theorem 5.1. Theorem 5.1 says that if a segment joins the midpoints of two sides of a triangle, that's this right here, that's a mid-segment, then there's two conclusions. So it's if it's a mid-segment, then it's parallel. In other words, let me show you what the symbol is we use for parallel. We would say that this side is parallel to that side. So the mid-segment is parallel to that third side, and it's half as long. So if this segment right here measured 10, then this segment here would have to be 5. So that's what the triangle mid-segment theorem says. It says if this is a mid-segment, then it's parallel to this side here, and it's half as long. So that's theorem 5.1, the mid-segment theorem. So let's go ahead and look at an example. Now in this example, I have triangle, look at triangle ABC. Triangle ABC, and notice that I've drawn 1, 2, I've drawn all 3 of these things are mid-segments. So this is going to be congruent to this is congruent to this, and this is congruent to this. In other words, I have all 3 mid-segments. So now we're supposed to fill in these blanks. So the first question is, and I should go ahead and put a segment symbol there, DE, segment DE, that's this guy, is parallel. Well, I mean, I think it's kind of obvious. If we're talking about this mid-segment here, it must be parallel to this side here. So this is going to be segment AC. The next one, now we've got segment FE. Segment FE, that's this segment right here. Well, it has to be parallel to this segment right here. So this is going to be segment FE. The next one, now we've got segment FE. Segment FE, that's this segment right here. Well, it has to be parallel to this segment right here. So this is going to be segment FE. segment AB, this one right here. So this is going to be segment AB. These are kind of some of the types of questions you guys are going to see on your homework. Okay, question number 3. If segment AB is 21, that's the length of segment AB is 21. So let's go ahead. I'm going to erase what I have up here so far because I want to make sure that this is pretty clear. So it says that segment AB, that's this whole segment right here. If that's 21 in length, what can we conclude? Well, since we know this is the corresponding mid-segment to that side, I know that this side here, FE, has to be equal to 1/2 the length of AB. And that's exactly how we would write it. And if we go back and look at the theorem, that's exactly how the theorem is written as well. In other words, FE is going to be 1/2 of 21, which is 10.5. So this is going to be 10.5. Question D, if BE is 7, so now I've got to go to BE. So let's see here, BE, this guy right here, that's 7. What can we conclude there? Well, we can conclude a couple of things, but the most interesting thing I think pertinent to this problem is, guess what this length here has to be? Well, it has to actually be exactly 7. So I'm going to say that DF is equal to 7. Now you might say, wait a minute, Mr. Allen, you just told me on the last problem that the mid segment was the half of the length of the opposite side. So since this was 21, this is half of 21. So if this is 7, shouldn't that be 3.5? Well, the answer is no, because if this is 7, then this is 7, which makes this whole side 14. And if this side's 14, then this has to be half of that, which means this has to be 7. So that's why that's 7. And then the very last one we're going to look at here is, let's do it in green, segment DE. So segment DE, this guy right here is 10.2. Can you think about which side would be something related to that 10.2? Well, I'm hoping that you recognize that DE is a mid-segment, and then this would be the corresponding side with that. So if this is 10.2, guess what the length of AC has to be? Well, it has to actually be double that. So that's going to be 20.4. So AC is 20.4. Does anybody have any questions on that first example? So those are pretty simple, but I wanted you to be aware. Those are kinds of things that you might see on your assignment in WebAssign this week. Oops. So let's look at one that involves a little bit of algebra. Can you guys take a guess on what you think the name of this segment is right here? I hope that you notice that BC is what we call a mid segment. That's the big idea in section 5.1. It is a mid segment because it joins, this is a midpoint, that's a midpoint. This is a midpoint based on those markings. So this is a mid segment. So now we're going to use this theorem. We know that this length is x plus 19. We know that this length of the triangle is x plus 29. And I know according to the mid-segment theorem that BC is equal to 1/2 of RT. The length of BC is equal to 1/2 the length of RT. So again, I'm using this theorem, theorem 5.1, to come up with my equation. So what is BC? Well, BC is x plus 19. What is RT? RT is x plus 29. So this is what we need to solve to figure out our answer for this particular problem. So the way I'm going to solve this equation, just using algebra, is I'm going to multiply both sides by 2 first. When I multiply this side by 2, 1/2 times 2 is 1. So that leaves me with just x plus 29. That's why I multiplied by 2. And then this side here, I've got to use this property that you guys hopefully remember called the distributive property. The distributive property tells us that this is going to be 2x plus 38. Now we've got to figure out how to get all the variables isolated. So I think I'm just going to minus x on both sides. So that's going to give me x plus 38 equals 29. And now what I need to do is minus 38 on both sides. So x is going to be equal to, looks like a negative 9. Negative 9. Now that's interesting because it seems weird that x is negative 9. Wouldn't you agree? But let's plug negative 9 into here. If you plug negative 9 into here, you get 10. If you plug negative 9 into here, you get 20. Is 10 half of 20? It sure is. So it does make sense that x is equal to negative 9. Okay, we're going to go ahead and move on to section 5.2. But before we do that, I would like for you guys to answer a question. So in my poll that I'm going to launch right now, I have a question for you. And if you've been paying attention, it should be very easy for you to figure out. Please enter your answer. Okay, another minute or so, and then I'm going to move on. Please answer the polling question. I appreciate you guys being here and attending, but I'm more interested in you guys actually paying attention and maybe even taking some notes. All right, so we've got 6 people, 7 people. Okay, thank you very much. It looks like most of you were paying attention. I appreciate that. All right, so let's go ahead and look at the next section. Section 5.2. Section 5.1 was on midsegments. Section 5.2 is on perpendicular and angle bisectors. So I've got 2 theorems here, and they're basically converses of one another. So I'm basically going to focus on this first one, and this is called the perpendicular bisector theorem. We've already talked about what perpendicular means. Perpendicular means that it forms a right angle. And bisector, we just talked about that in our first example. That means that it goes through this midpoint. In other words, those 2 segments are congruent. So here's what theorem 5.2, the perpendicular bisector theorem, states. If a point is on the perpendicular bisector of a segment, so here's segment AB. This line right here is what we call the perpendicular bisector. And the reason it's perpendicular is because it forms a right angle. And the reason it's a bisector is because it divides it into 2 equal parts. Well, it turns out that if it's on the perpendicular bisector, then we can conclude the following. We can conclude that this distance here is the same as this distance here. So basically what I'm telling you is if point P is on the perpendicular bisector of a segment, if this was 7 units, then this over here would also have to be 7 units. Hopefully you can kind of see why that is, because these 2 triangles are going to be congruent for a very similar reason to what we did on the warm-up today. Not quite the same, but very similar. We could use, in fact, in this case, we could use SAS. So let's see an example of this. This is something that I actually grabbed off of a geometry test. And by the way, I should let you guys know, we will not be having any more quizzes or tests until the final exam. Okay, so the final exam will be the next exam / test / quiz. So no more quizzes or tests. You just need to be getting your homework done, attending classes, and studying, reviewing for the final exam. So here's what this says. It says for which values of x and y is AD a perpendicular bisector of segment BC? So in order for this to be a perpendicular bisector, guess what has to be true about segment BD and segment DC? Well, they have to be congruent. So BD has to equal DC. So what is BD? Well, BD is 5y minus 1. DC is 10 minus 3x. Similarly, let's do light blue. This distance has to be congruent to this distance. In other words, AB has to be equal to AC. So 3x plus 2, because that's what AB is, has to be equal to 5y plus 3. So now we've got a little bit of a dilemma here, and this goes back to our algebra class. We've got two equations and two unknowns. This is called a system of equations. And now I'm going to have to solve that system. Now, before I solve that one, I'm going to go ahead and clean this up a little bit by adding 3x over here to the other side, and then adding 1 to the right side. So what I did here, if you wanted to see my work, is I plussed 3x here, I plussed 3x here, and then I plussed 1 here, and I plussed 1 there. Now notice, I can't add 3x to 5y because they are not like terms. Similarly, over here on this other side, I can clean this up a little bit. This is going to be 3x minus 5y equals 1. So now I can use both of these equations to solve my problem. Now, hopefully you remember there's a variety of different ways that we could solve this, but I think the easiest way is just elimination, if you guys remember the term elimination. And it works out really nicely here because all I have to do is add these two equations together. 3x plus 3x is 6x. 5y minus 5y is 0. 11 plus 1 is 12. Therefore, x is 2. So now we have x. That was actually pretty simple once we did a little bit of work with that. And since I have x is 2, now I can figure out what y is. I'll just plug that into this right here. So that's going to be 3 times 2 minus 5y equals 1. So 6 minus 5y is equal to 1. Negative 5y is equal to negative 5. Y is equal to 1. Now, guys, I went pretty quickly through the algebra on that, but that's how it works. So what I did here is I used the perpendicular bisector theorem to conclude these two segments had to be equal and these two segments had to be equal, which generated these two equations right here. And then I solved them using elimination. So I'm trying to do a little bit of a review of Algebra 1. Does anybody have any questions on that example? Okay, I'm going to go ahead and move forward. Oops, not that far forward. So this is the last theorem. And again, this is kind of like the first one we did. And by the way, we have about 15 minutes left. This one is Theorem 5.4 is the angle bisector theorem, and then its converse. Again, I'm going to just focus on this one up here. The converses, you remember, we just take the if and the then and switch them around. Here's what the angle bisector theorem says. It says if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So this is saying almost the same thing as the last theorem. So if this ray right here, ray QS, is what we call an angle bisector, and then we pick some point S on it, By the way, angle bisector means that this angle is congruent to this angle. Then it turns out that this distance and this distance have to be the same. That's all it's saying. And again, we're dealing with more congruent triangles. So let me say it again. If you have and we're talking about angle PQR, if we bisect that angle with QS, and then we pick a point on that angle bisector, we'll call it S, it turns out that this segment's length has to equal this segment's length. So let's look at a proof of that. Oops, too far. So let's look at the proof of this, and I'm going to go through this proof kind of quickly. So I apologize, but you may want to pay attention because there may be a polling question about this proof in a second. So here's what the proof says. This is the proof of the angle bisector theorem. It says, given that ray QS bisects angle PQR and that PS is perpendicular to QR, that's why there's a little right angle symbol, and RS is perpendicular to QR, we want to prove that those two segments are congruent, namely segment PS and segment SR. So here are our statements, and here are our reasons. So I want to prove the theorem we just discussed. So I'm going to start with number one. I'm going to say that QS bisects angle PQR. If it bisects angle PQR, by the way, that's given. If it bisects it, well, then that implies that angle PQS, that's this angle right here, has to be congruent to angle RQS. That's this angle here. So now we have an angle congruent to an angle, and that's going to be by the definition of an angle bisector. Now we also know, based on the given, that PS is perpendicular to PQ and RS is perpendicular to RQ. We know all of these things are true because that's given. And by the way, if all of those are perpendicular, then step number 4, we know that angle, let's see here, QPS and angle QRS have to be right angles. If this is perpendicular here and this is perpendicular here, then those angles are what we call right angles, and that's by the definition of perpendicular. And by the way, if they are right angles, that means that they are congruent. And that's because all right angles are congruent. And by the way, then we've got another angle congruent to another angle. So now I know that this angle right here is congruent to this angle right here. Now I'm going to use that little trick that Ishmael reminded us of earlier today, and that is that segment QS is going to be congruent to segment QS. And that's by the reflexive property. And that gives us a side. Now I have a very important question. I have an angle, and a side congruent, so that tells me that triangle QPS is going to be congruent to triangle QRS. But why? Is it going to be because of angle, side? Or is it going to be because of angle, side, angle? So the question, to answer that question, we simply need to ask the question, is this side right here, is QS included? Is QS the included side? The answer is no, it is not. It is not the included side. Therefore, step number 7 is going to be AAS. Angle, side. So then finally in step 8, we can conclude that PS is, I'm going to go ahead and write it this way, which is the same thing as saying that PS is equal to SR. And that's going to be by, as I think it was Sean that mentioned this earlier, CPCTC. So there's our proof. So we now know that this statement that I stated in this last slide is true, and it's always true because I have proven the theorem. And then once it's proven, it's always true. Okay. I have another poll question for you. So if you would answer this next poll question, and then we will do the last example. I need to end the first poll, though. And now let me start the second poll. Sorry here. There we go. Okay, you should see the poll.
Hey, Mr. Allen, can I come to your room and ask a question real quick?
Yes, sir.
I'm going to mute my mic. You want to mute yours real fast?
Sure. If you want to make it up, let me know and I'll see you. Okay, perfect. Thanks. All right, I'm back, guys. Sorry about that. Okay, so hopefully you've answered the poll. Again, if you've been paying attention, the poll should be very easy, and it's pretty clear who is paying attention and who is not. So again, the point of the poll isn't to stress you out. I'm just basically trying to figure out who's paying attention and who's not. So we're going to go ahead and wrap up the lesson here today here with our final two examples, and then we'll get the exit ticket, and then we'll call it a day. We got about 7 minutes left. So example 4. Now again, we're going to use this theorem here, the angle bisector theorem or its converse. Okay, the angle bisector theorem, which we just proved, or its converse. So question number 1, or question A, I guess I should say. Question A is asking us to find the length. Remember, this is the length of segment QS. What is the length of segment QS? So QS is this segment right here. So what we need to notice is that this ray right here, this green ray PS, is an angle bisector. We know it's an angle bisector because you can see right there that it shows that those angles are congruent. It's an angle bisector. And if it's an angle bisector, guess what has to be true about these two segments? Now, I guess I should have probably drawn in these being perpendicular. So I kind of messed that up, but we can figure that out from there. So we just need to write an equation, and that is something about QS has to be equal to SR. And in this case, we know that QS is 4x minus 1, and SR is 3x plus 2. So we just need to solve this equation, which is going to be very simple to do. We're going to minus 3x from 4x, which gives us x. We're going to add 1 to 2, which is going to give us 3. So we know that x is equal to 3. Now be careful. If this had been a quiz question, this is not where you want to stop, because this question didn't ask us for s. It asked us for the length of QS. So now what I have to do is I have to plug this 3 into this 4x minus 1. So let's go ahead and do that, maybe in a different color. So QS has to equal 4x minus 1, but now I can put the 3 in there. So that's going to be 4 times 3 minus 1, and that's 12 minus 1, which is 11. So QS's length is 11. QS's length is 11. All right, last question. This may be the easiest of all of them. So this is kind of a nice way to end. Question B says, find the measure of angle WYZ. Well, let's see here. WYZ is right there. We want to know the measure of this angle right here. That's the angle we're looking for. We want to know what is the measure of this guy right there. Well, here's what we got to do. We actually are going to use, I'm going to go back to this slide. We're actually going to use the converse of the angle bisector theorem. The converse of the angle bisector theorem tells us this. If this segment right here and this segment right here are congruent and perpendicular to the sides of this angle, then guess what? This ray here, QS, this ray here has to bisect the angle. In other words, this side has, or this angle has to be congruent to that angle. So we're actually going to use, the converse of the angle bisector theorem. Since this is congruent to this and this is perpendicular to this, I mean, it's pretty clear. The measure of angle WYZ has to be 28 degrees. And the reason it has to be 28 degrees is because this angle was also 28 degrees. Okay. Well, guys, that ends it there. We have about 2.5 minutes left. What I'm going to do right now is I am going to send you my exit slip, and I'd like you to fill that out before you leave. And I'm going to stay on here for as long as I need to help answer any questions that you might have about the assignment or about the presentation that I just made. And please be aware, you are more than welcome to this PowerPoint. If you would like to have it, I will be glad to send it to you. Or I'd even be glad to send it to you with the answers. Okay, so that's it for today. I will hang out here for questions. Again, don't forget, I actually have another video already posted on YouTube explaining all this stuff. If it seemed like I went really fast, I would encourage you to watch that. So have a good day, and I'll hang out here if you have any questions.